Hello all and welcome back. So in this video, let us now continue our discussion on implementing stack using linked list. Now in the last video, we saw that how using a linked list, we were able to perform each and every operation, but the pop operation that was taking a complexity of O of n. Though that is fine, like we can still implement using the traditional linked list approach, that complexity is something which I would like to work upon, right? Trying to get it to O of 1 or something better in some way. Okay. So I asked you to think about this in the last video. Pretty sure you must have like kind of wrapped your head around that. And glad if you were able to come up with a solution. So the thing is that I can directly give you the solution or make you code the same. But I want to make sure that, the overall thinking horizon is basically expanded so that such types of problem we can tackle when going forward. Great. So now let us come back and discuss that how exactly can that be done, right? Now, in the video where we discussed about arrays versus linked list, if you remember, we discussed that how linked lists are very good for write heavy operations, provided we are inserting things and deleting things from head. So if you remember, we'll write that down as well. When we insert or delete from linked list head, complexity is O of 1, right? So I hope each and every one of you remember the same thing. Now, well, that is actually the basic idea behind using the same now. Let's say if I'm creating a linked list node, okay? So a node will be there for sure. That's a basic overall component of our linked list. So node is there. But now what I'm saying that, hey, this is my node. When you ask me to add, when you ask me to add, what I'm going to do is I'm going to add into starting of my linked list, right? So that's the whole idea. Let me create a stack as well, everyone. So let's say this is my whole stack. Now, when you are asking me to add one, I added it. That's a basic first node. When you ask me to add two, what I'm doing is instead of adding it towards the end of our linked list, the traditional way, I become a little smart. And what I do is I add a node toward the starting of my linked list. Something which we have done, of course, add insert in the start of my linked list. And if you see this now, so let's say this is first, this is second. In a way, let me just expand it a little bit. Let me just expand this so that we have 4 elements. Great. So if I just join them, everyone, and make it 3 and 4. So all I have done is I have just started adding to my head of linked list, inserting everything in the starting. And now I think lots of you might be able to think, a lot of you might be able to now understand that how I will be able to now do everything in that space. So pay attention. If you ask me to push, I am pushing in the direction of head only. So I'm pushing in the head. So what exactly that becomes, everyone? Let us write the operations as well now. The first is push. Okay. Insert at start. So I am able to get the same thing in O of 1 complexity. Let us see the next one, which is pop, the one which we were actually worried about. The pop operation, right? That was the operation which due to which we have to leave the last full overall implementation. It is pretty easy as well. We can just move our head to next one, head to next element. So I hope now you are able to see how this is pretty great, right? This is also O of 1. if you remember to delete something from to delete at head, right? To delete the head, it was just some operations, some easy operations. So if you ask me to delete this particular node, let's say if you ask me that, hey, you don't want 4 in your stack now. So I will delete it from here. I will also delete it from here, right? And for my head, I will just ask, hey, head, can you become the next node? And I think that's pretty much similar. One line thing, head is equals to head dot next. So this is like the smart way. This overall thing is like the smart way of doing my pop operation in O of one type. Okay, so let us move and see other operations, everyone. Next one can be top or peak. I think that can also be very nicely done. We just have to get the data of our head. So if you give me head dot data, again, this is O of one operation. Okay, so in this approach, you will see that we don't even have to maintain a tail. Just by changing, thinking in a different way, the way we are storing our data, we have actually achieved each and everything very smartly in a very good complexity as well. Right, now let's talk about size. Size, I think, again, is some place where we might have to go through a O of n route, right? So what we have to do, if you ask me for size, I have a head, and let's say I keep going forward. I feel that it's going to be a problem, right? If you ask me to do this, it's a problem. But again, then we can handle that just by making a size variable. So I will maintain a size variable as well, everyone. And that is going to help me, right? That is as good as you can think of. I don't have to do anything now. It's going to be so much easily tell me that what the size is. So we can maintain a size variable. And every time you will add push, I will just plus add it by 1. Every time you pop, I will just subtract it by 1, which will imply again O of 1 approach, right? So I just have to go and return this. So you will see one thing here, everyone, that using some space, I'm able to basically make my time complexity good, right? So in the space and time complexity, when we learn about that, and in many questions going forward, we will see that how this overall trade-off between space and time can be handled in many algorithms, in many questions, to get a better complexity by just using some space. The very good example is here, right? So we are able to get a very good overall complexity just by using a size variable. Same thing we were actually able to do in insert take input of our linked list when we just use a tail pointer to go from ON square to ON approach. Or sorry, ON to O1 approach, right? So that is the overall mindset, everyone. So to make sure that we can actually handle these things, we have just created a variable, which is absolutely fine, right? It's a constant variable. It is not going to depend on input. And the last one is empty. This is of course going to be a easy work now since we have size as well. Normally we have the head as well, so we can calculate it by both ways. So if size equals to 0, we can tell if our overall stack is empty or not. And now if you will see, we have implemented each and every operation of my stack using linked list in a O1 time. So I hope you understood exactly that how we have built our solution. Instead of just starting off with this approach, I wanted to make sure that you understand the problem in the last approach which we discussed. Okay, everyone, now this is the kind of analysis, the kind of mindset, the problem solving approach which I want all of you to develop by solving questions, by understanding things in depth. Because once you do that, then it will be a lot easy in creating good softwares, cracking any good companies. Okay. So great, everyone. I hope this was a lot clear now. In the next video, we will now implement our whole linked list, whole stack using linked list from scratch. Okay. So yeah, just try to give it a try if you want. And in the next video, you can just check your answer along with me. We are gonna code it from complete scratch, just using the node, and you will see that how everything works fabulously well. Okay, thank you.